All right, I'm going to do this video to talk about the equations of lines. And it'll be quite a bit of what I talked about in class. Some of you may not have been in class, or some of you may, from class, may want to see, review what we did in class, and it will help us understand a little bit about what's going on in problems 50, 51, and 52. This is in section 2.2 or 3. I can't remember now. Okay. But anyway, the section on lines, I think it's 2.3. Okay. First of all, you need to know what an equation of a line means. For instance, if I said y equals 2x plus 3, that's in the form that many of you may have seen in earlier classes, y equals mx plus b. An equation is just a way to match x's with y's. So, for example, from this, I could make a table of numbers that match these up. It says that if x was let to be 0, then you can find the y by doubling that and adding 3. So 2 times 0 is 0 plus 3. 3 matches with x equal to 0. What matches to 5 in x? Well, 2 times 5 is 10 plus 3 is 13. And if you were trying to graph this line, these would be points on the line, and there would be a whole bunch more. Any number that you want to put in for x, you would double and add 3, and you would find the y. So if you put in minus 2 and you doubled that, you'd have minus 4 plus 3, you'd have minus 1. An equation of a line is just a matchmaking tool. It matches x coordinates to y coordinates. So if you have a couple of points, how do you find that matchmaking tool? So if I had 3, 5, and minus 2, 1, let's just say, how do we get to that matchmaking tool? Either in the y equals mx plus v, or in this form, or in this form. So I'm going to try to get to this form first. Now, you may have found the slope of a line through a formula that said do the y coordinate from the second point, and you could decide this is the second point and this is the first one, or this is the first one and that's the second one. Anyway, you take the y coordinate from the second point. So if I called this one the first and this one the second, the y coordinate from the second would be 1, and then the y coordinate from the first point would have been the 5. The x coordinate from the second point would be the minus 2 minus the x coordinate first one, and that's the way you do it. Find the slope. But what is the slope? Well, it's talking about a rate of change. For instance, and I use this in class, if you were driving a car at 60 miles per hour, per 1 hour, you would take it times the amount of time you drive it, and that would give you the distance. For instance, if I drove for 2 hours, 2 times 60 miles per hour, 2 hours, the hours would cancel, and I get 120 miles in 2 hours. 3 hours, and so it's telling us what distance matches with what hours. That's what an equation does, matches up variables. And This is kind of the rate of change in how this one goes to this one. Every time t changes here, let's put them in. If t was 1, the distance would have been 60 miles. If you went 1 hour at a rate of 60 miles per hour, you end up with 60 miles. If you go for 2 hours, 2 times the rate of change makes 120 miles. And 3 is 180 miles for 3 hours. Okay? So that's what equation is telling you, how the time relates to the distance. And there's a rate of change that's involved. When we're finding slope, we're finding the rate of change. Now, we can do this. We can go, if I call this a second, I would do 1 minus y from the first point, 5, over x from the second point, minus 2 minus x from the first, 3. So the rate of change for these 2 points is 1 minus 5 is negative 4. Minus 2 minus 3 is minus 5, which is the same as 4 for 5, because a negative divided by a negative is positive. So the rate of change is the change in the y is 4 for every change of 5 in the x. Let's take a look at that another way that I like to do the slope, because I think it's a little easier to do. I just write the points in the graph. I could do 2, minus 2, 1, and 3, 5, the x's and y's, and say, how is the x changing? Well, it looks like it's going up by 5 as the y goes up by 4. So if I follow that pattern, I could go up 5 more and make 8, and 4 more, 9. So not only does 3 match with 5, but 8 matches with 9. And I could go up 5 more. 13 would be a match with 13, going up 4 more, etc. So the slope is how much the y changes compared to how much the x changes. So it's 4 over 5. Now, if I wrote these points the other way around, the 3, 5 on top and the minus 2, 1 next, I would have gotten 3 to minus 2 would have been a minus 5, and 5 to 1 would have been minus 4, and I would have got this, but that's the same as that. Okay, now, what happens in an equation like this? What's going on? Well, you can see this side is going up by 5, this side's going up by 4. If I take this one, the plus 4 times the x numbers, 4 times negative 2 is negative 8, 4 times 3 is 12, 4 times 8 is 32, 4 times 13 is 52. So I'm taking how the y is changing times the x. And similarly, or oppositely, I'm going to take the change in x times the y values. So I'm going to take 5 times the y values. And when I do that, I get 5 times 1 is 5. 5 times 5 is 25. 5 times 10, a 9 is 45. And 5 times 13 is 65. And now let's look at the changes. The change on this column, it's going up by 20. Up by 20. And so is this column, going up by 20, up by 20, up by 20. So if this were a race in these columns, one of them is ahead of the other one always by the same amount, because they're both going up by 20, so they're going to stay the same distance apart. So I could take the 4x column, these numbers, and subtract the matching ones from the 5y column, and it should be always the same amount apart. -8 subtract 5 is -13. 12 minus 25 is -13. 32 minus 45 is -13. So here is an equation for the line through these 2 points. Now, I went through a lot of work to get that, but if I were doing this, I wouldn't be doing all that work because I would know how it works out. I would say, okay, the 4 was the change in y. So I would go to here and say 5. I could do it this way. 5 goes to -1. That's -4. So I took the change in y. So I turned these points around. I'm going the other way. Maybe I shouldn't do that. That might confuse you. Let's just do it the same way. Let's call this the first and this the second. So 1 to 5 is a change of 4. That's how the y's are changing. I take that number times the x. Then these are always going to be the same distance apart, so I'm going to subtract them to get how much apart they are. Then I'm going to do, I went 1 to 5 was up 4, -2 to 3 is up 5. That's the change in x. And I'm going to take that times the y, and that turned out to always be, and I plug in any point, like 3 here and 5 here, and I get 12 minus 25. 12 minus 25 is -13. Or I could have put in -2 times 4, -8, and 1 times -5 is -5, and -8 minus 5, -13. So I don't need to do all this. This was just kind of an explanation of how this works. And I can get this equation in my head. And what they want you to see by doing this standard form of the equation of a line, A is the change in y. And it's times the x. And this should be a subtract, and so the opposite of what b is the change in x, because we want to always subtract. Now they wrote it plus, so then b would be the negative of the change in x, so you have to change this around. The negative of b is what the change in x is. So if I write an equation like this, the slope is simply the change in y, a, over the change in x, which is the opposite of b. So if I wanted to read the slope from this, that's what it is. Now, they wanted you in this problem to show that that's what it is, and they said to do that by solving for y. So I'm going to do that here. I'm doing question 51 now. So ax plus by equals c. If we're solving for y, we're going to subtract this from both sides, and we get by equals -ax plus c. So I subtracted ax from both sides. And then I'm going to divide by b. And over here, I have to divide both of these by b. I've got to divide this whole side by b. And I get y equals -a over b x plus c over b. That is the slope. So They wanted you to show that the a over negative b is the slope, but this tells you how that kind of works. That's the change in y, that's the change in x with a minus in between. If you put a plus, then the opposite of this would be the change in x. Okay. So this is how you can get to the standard form straight from the 2 points. Let me remind you again. All you have to do is say, oh, I'll do it thinking this is the first second. The y went from 5 to minus 1. That's minus 4x. Change in y is minus 4 times x. Subtract. What did the x do? Well, the x went from 3 to minus 2. That's a minus 5. Oh, a minus is plus. Now, what's the constant over here? The c. Well, let's take one of the points. Let's do, I'll avoid the minus. I'll just do the 3 and the 5. And negative 4 times 3 is negative 12. 5 times 5 is 25. Negative 12 plus 25 is positive 13. That's the equation in this form, and I didn't need to do any of this. I could do almost all of the math in my head. I did a little bit here. And it's the same as this, except this is just this side multiplied by negative 1, and this side multiplied by negative 1. So if you multiply both sides of this by negative 1, you get this equation. If you multiply both sides of this by negative 1, you get that equation. These are the same equations. Okay. Now, you probably learned how to find the equation this way. So let's do that. We found the slope between those two by using this formula, which is probably what you used. And then you said y equals the slope. I'll use the positive one because the two negatives cancels. 4/5 times x plus some number. And I find this confuses students, and finding this number confuses students, especially with the fraction in here. But I'll go ahead and use the 3 up here and the 5. The 3 is the x, so I'm going to put it there. And the 5 here, and I got to take the 3 times 4/5. And some students have struggle with that. The 3 is 3 over 1, so it's not 3 times both of those. It's 3 times the 4 and 1 times the 5 plus b. And we got to figure out what b is. So we have 5 equals 12/5 plus b. So to find b, we have to subtract 12/5. That happens to be 2. 5 goes into 10, 2, and that leaves 2 left. So this is 2 2/5 from 5 is 2 3/5 equals b. Some students think they're done there. No, we're looking for the relationship between the x and y coordinates. We need to complete the relationship, and that would be y equals 4/5 x plus 2 3/5. Now, with all the fractions, students get frustrated. They're not sure if they're right, and they don't want to check it. If you do it this way, you don't end up with fractions, if these are not fractions to start with, and pretty easy to check. You can put in minus 2 for the x and 1 for the y, should come out 13. You can put in 3 and 5, should come out to be 13. You can put 8 in for the x and 9 in for the y, should come out to be 13. If it works for more than one pair of numbers, you're pretty sure to have the thing correct. Okay, I'm not going to talk much more about this method because that's the one you've probably seen a lot. It's in the book. I'm just reminding you of that one. This is the way I like to do them. Or I like to do them this way. And if you go to calculus, they like to do it this way also. And let me kind of explain how this works. You got 2 points. We figure out the slope is 4/5. But that should be the slope between any of these points and another point, x, y. Any point that's on the line should have the same slope from here to here as it is from here to here or from here to here. So we go to here and we say the slope is going to be, I'll do y minus 5. So this is y. I'm thinking this is y2, but I'm just calling it y. Y minus 5 over x minus 3. And then I'm going to multiply both sides by x minus 3. This side, that cancels. And so I get y minus 5 on this side. I'm going to switch the sides here. I'm going to get y minus 5 equals the slope times x minus 3. So this was any y. This was y from point 1. So it's y minus y from one of the points equals 4/5, or the slope. So I'm going to put it in general now. The slope times x from any point minus the x coordinate from the point that we're choosing. We'll call that x from one of the points. And that's what this is. So this is the same equation as this. This one just looks messy because they solve for y. And this or this, these all are the same equation for the line. This is called the point slope formula. You need to know the slope and the y and x from one of the points, and then you leave a y and an x in the equation so that we've got a way to relate the y's and x's. This one is called the standard form, and it's using the change in y in front of the x and the change in x in front of the y if you subtract. And so here in 52, they wanted you to, I showed you how to get this from an equation here. Kind of. I didn't do it exactly, but you got what it is. This one is, they said, the equation in slope-intercept form. So they wanted you to solve for y. But I'm going to say that this is going to be y equals the slope. And so that's change in y, which is in front of the x, over the change in x, if it's minus, which is in front of the y. So it's 5/7 x plus the y-intercept. And the y-intercept is always found by letting x be 0. So if I put 0 in there, 7 times 0 is 0. So the y-intercept, I divide by minus 5, and I get 25 divided by minus 5 is minus 5. Okay? Now, I could have done this the way they expect you to do. They expect you to subtract 7x from both sides. And so you would have had minus 5y equals negative 7x plus 25. And then divide by negative 5. And you get plus 1y The y-coordinate can be found by taking, see, negative 7 divided by negative 7 is the same as 7 over 5. Taking 7/5 times the x value, and then 25 divided by negative 5 is negative 5. I did it a little differently, and then I did it the way they expected you to do it. Okay,